So yesterday we learned about the frequency wavelength of EM spectrum, right? Today we will be doing the last topic in this particular chapter. Probably I'm hurt. All right. So it's called polarization. Let's do that, and then we'll continue with the workshop. Yes. Don't worry, I'll do it today. Today is a small topic. I think we will be finished very quickly. Okay. Okay. So polarization, kids. Polarization is a concept that we basically write when a wave is made to oscillate in one plane only. This wave will be called plane polarized. Alright, so I'm going to explain this to you. Just remember, in fact, I'm just going to write this in a different color, that polarization can only take place in transverse waves. Polarization cannot happen in longitudinal waves. Remember that. So what happens is that suppose a source, a natural source like sun or a bulb or something like that, sends waves in this direction. So this is basically, you can write wave direction. So the waves oscillate in all the planes: vertical plane, horizontal plane. Oh my god. Planes at certain angles, like this. Alright, kids? So these waves are like that. This sort of waves are called unpolarized wave. Alright, kids? Do you guys understand that they're vibrating in all directions basically?
Yes.
Now, what we do is we let them pass through a polarizing filter. Now, this filter basically is sort of like that, which basically means that it will only allow waves, wait, to pass through this vertical plane only. All right. This filter is, by the way, called a Polaroid, like that. So when it passes through it, the waves which are only vertical can pass, because right now it is vertical, and no other waves are passed because they cancel out because of the filter being 100% vertical. Do you guys understand that? So now what you get is, after passing through it, is polarized in vertical plane only. Is it clear, everyone?
Yes.
Basically, I just want to explain this using waves as well. Like if you see a wave could be like this, and then uh, the other wave could be vibrating like this, horizontal plane, and there could be like many of these. So only those waves which are vertical vibration right now that can pass. In this case only, if you rotate it to horizontal, it will only allow horizontal, or at a certain degree it will only allow that. So we can basically comment that when an unpolarized light slash wave passes through, specifically like in this case only, the vertical wave will only pass through the vertical slit, and others will be blocked. Is it clear, everyone?
Yes.
Please write this down. Now you guys need to redraw this thing. For this time, what we will do is that we are gonna put another filter which looks like this, like that. Oh my god, so bad. My bad, sorry. This time we only allow it to move like this. Now this filter is called an analyzer, and it is rotated at 90 degrees. Like it's basically vertical and then rotated 90 degrees. Is it clear?
Sir, can you please repeat?
Sorry?
Can you please repeat?
Yes. Basically what I've done is I have this filter like this, okay?
Yes.
That looks like this basically. And I have now rotated this filter. How do I resize? Okay. I have rotated this filter like this. Do you guys understand? Like that.
Yes.
Now, when it is vertical, it's giving me like all the vertical waves are passing. But as I keep on rotating, the vertical part will start cancelling. And when I've completely rotated to 90 degrees, then I would see no wave, because it's completely horizontal, so no wave is now seen, only darkness. Is it clear?
Yes.
As everything is now blocked. So you can basically write it down. that as the
So it's
analyzer, G, sorry,
it's called an analyzer.
yeah, analyzer, because we want to know what kind of wave is there. Do you understand?
Yes.
As the analyzer is rotated to 90 degrees, the intensity of wave reduces to zero. Correct?
So it's a Polaroid, but this is before wave is
Yeah, because first we changed the wave into vertical, and then we rotated to slowly rotated to 90. So basically, it became darker and darker, and ultimately it was completely blocked. Understood?
yes, yes.
Now the thing is that we also want to know how to create a Polaroid. So it's pretty easy. It is made up of a transparent polymer material. This polymer has long chains of molecules all aligned in one particular direction. Is that clear?
Yes.
Now, obviously, it follows conservation of energy. So you would ask, what happens to the block waves? The waves that are blocked transfer energy into heat to these molecules. This is where the energy of the waves go when they're blocked. Get it? Ouch, 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 ouch. Okay. Now there's so many uses, right, of these. You can write this down. Uh, Raza, Furqan, Fatima, Abdullah, you guys understanding this?
Yes, sir, so far okay.
Okay.
So the analyzer is a type of polarizer.
It is what? Sorry?
The analyzer is a type of polarizer.
Yeah, yeah, it is the Polaroid. We call this analyzer because we're now looking at what direction are the waves generated in or passed through the first one. Get it? Now there are many uses of Polaroids. First use is in sunglasses. The real sunglasses, which are the expensive ones. अभी अम्मा जी चाय दे दें बस. Green green. The glasses, they absorb vibrations in other directions to reduce eye strain and glare. This is why on sunny days on beaches, because water reflects a lot of light, even snow reflects a lot of light. So you gotta basically use very good sunglasses to protect your eyes. Do you guys understand that?
Yes.
Also, you know, cameras which are like good cameras, also use these to take photos with less glare, because you see why iPhone camera is so good even though it is less megapixel than so many Androids that we have, because their cameras have Polaroids, which basically reduces the light that is reflected from the background. So the image that they're looking at is taken in, and the background is bit, shown in a way where it shows less glare. That is why the pictures come very neat. Do you guys understand?
Yes.
Yes, so the if the wave entering the analyzer is tilted to 45 degrees, then the wave coming out would be of more intensity than zero, right? But it will be still less.
If it's tilted to 45 degrees, one portion of vertical will be shown, but it will not be as intense as before. You get it?
Yes,
Yeah. One of the best uses of this is in 3D movies. If you ever go and watch a movie in 3D, you might realize that they give you glasses to wear so that those 3D effects come, right?
yes,
And if you remove those glasses, the screen looks a little bit blurred. Have you noticed that?
yes,
The reason why that depth is created, because in those glasses there are two filters put in. They put in two filters. Like one is the vertical filter and one is the horizontal filter. And in fact, in a 3D movie, basically two projectors are used. There's not one projector. There's only like if you use two projectors, what they do is there are two different footages running on it. Do you understand?
Yes.
One in the horizontal direction and one in the vertical direction. So if you wear the glasses, one of your eye looks at a different movie, and the other eye looks at a different image, which is at a certain different angle. So you feel like that it's creating that depth. Do you get it?
Yes.
So that's why those glasses, without glasses, you won't be able to exactly does that. So that's basically you can't see that movie without the glasses. That's why they ask you to purchase the glasses. By the way, what they do is these glasses that they use are very cheap ones. So you can buy it for about $1 in Pakistan. I don't know about Saudi or Dubai. It's basically in the market you can buy and go watch a movie. It's $1, like 300 rupees in Pakistan. But then the cinemas sell you it for probably 1,000 or 2,000. That's bad. No? They take extra money for that, because polymers are basically plastics and they're very cheap to make. By the way, they're not very expensive. But yes, if you buy original Ray Bans or maybe Gucci or something, they use very good filters for that. Those are made from really good polymers or glass, and that reduces eye strain to a certain level. That's why you feel so cool when you, I mean, not wearing cool, like your eyes feel cool looking at, sir, things in harsh sunlight. You guys understand that?
Yes.
so sometimes it's like red and blue, different color. Is there a reason?
Sometimes what?
It's different colors, like red and blue. Is there a reason?
It's just to a red color. It's just to make sure that the colors of the movie doesn't mix. So there are two filters there. One movie is of red color, one movie is of a blue shade. So they don't mix. They feel they create that depth effect to the color. Do you understand? That's about that.
That's
Because
nice.
red has a different frequency, blue has a different frequency, like we have studied just yesterday. So they don't want to interfere the images of the two projectors that are running in that. That's why they do that. Understood?
Yes.
All right. Now the intensity, yeah, that's what I'm talking about. Polaroid spectacles are, if they're very good quality ones, they're expensive. So Malice's law is basically explains how basically how much intensity is transmitted through a Polaroid. So we're gonna basically, there's no definition for this. They're not gonna ask that. You just need to remember that when theta is 90 degrees to Polaroid, no light is transmitted, and when theta is 0 degrees to transmission axis, that I'm going to show you in a bit, light can fully, yes, that's true, those are Polaroids, yes, fully pass through. Is it clear? Now let's look at this one. So suppose this is the direction of the wave, and there is a wave that is coming at a certain angle, right, like that. And the intensity of the wave right now is I naught. So this is initial intensity. You have placed a Polaroid vertical to the axis or the transmission, which means that the transmission axis is like that. This is called transmission axis. Is it clear?
Yes.
Now, obviously, this wave will have components of it. Like one component of the wave is going to look like that, the other component is going to look like that. Understood? So the vertical component will only pass because the transmission axis is right now vertical. So the wave will get a bit less intense because the horizontal component of the wave is going to get cancelled out. Is it clear? And you will receive intensity I. Now, just remember, if I draw a vector diagram, so this is the transmission axis. When the wave entered through it, it was at a certain angle like this. We can take this angle theta right here. Is it clear?
Yes.
So we're going to only look at, like, both sides will have the same effect, but we want to look at one side right now. So this basically makes an angle 90 degrees here. So if this is from the center, if this is the amplitude of the wave, then I would say that this one will be amplitude cosine theta because it's next to the angle. Do you guys agree?
Yes.
Where I want to tell you the intensity I naught is the incident intensity, and I is the transmitted intensity. Wait, Radha. Radha, this wave is basically at a certain angle to the transmission axis. Do you understand that? Let me just explain it again. So your transmission axis right now, it's completely vertical. You agree? This wave that you see here basically passes through it like this. Do you understand? At a certain angle theta along about the transmission axis. Is that clear? Is that clear, Raza? Okay. Now, if you look at this basically creates a right angle triangle like that. Understood? So the wave is like that. Let me just show you a wave. Do you understand this? Okay. So that means this portion of the wave is half wave, which is the amplitude. Because when you take a wave, the amplitude wave is taken like that. Do you agree? Okay, Raza? Which means if you look at this is 90 degrees. If this is amplitude, then the basically cosine theta is
Sir,
the adjacent over the hypotenuse. Yes.
so that distance is half the wavelength, right?
No, no. I'm trying to make it the other way. Like it's going like say how can I do that? I'm trying to make it the other way. Like it's oscillating like this, Emal. Something like this. Do you understand, Emal, like that?
Okay.
Okay. Now, because cosine is adjacent over hypotenuse, so this is adjacent, this is hypotenuse. So basically, the adjacent will be A, which is the hypotenuse, cosine of theta. Is it clear? Is it clear now? Because the transmission axis will only allow this portion of the wave or this part of the wave to go. It will just cancel out this one. Do you get it? Good. Now, in the intensity thing, we learned that intensity is proportional to amplitude square. And then I gave you the formula I over I1 over I2 equals to A1 square over A2 square. You guys agree?
Yes.
All right, now check this out. The initial intensity was I naught, the final intensity was I. Initial intensity amplitude was A square, final intensity amplitude was amplitude cos theta whole square. Get it?
Yes.
So can I write it as A square over A square cosine square theta?
Yes.
A square and A square will cancel out, which means that basically I will now be written as I naught cos square theta, and this is the Malus law that we need to remember. Get it?
Yes.
Yes, Shazib, Zirwa, Raza, Dania, everything is clear?
Yes.
All right, so do not forget about this. This is the only formula that you need to remember.
So
Now,
questions will come from this only.
sorry?
So questions will come based on this equation only.
Yes, and every single time it will be there. So, because this is a new chapter that they added last year, so they're testing it out every single paper. So right now you need to be aware of that. So if I draw a graph of intensity, this is watts per meter square with respect to angle theta as we move the analyzer or transmission axis. You guys need to remember that angles can be 0, 90, 180, 270 and 360. So at zero angle, you will basically when zero angle means that the wave is 100% aligned with the transmission axis. So it will fully pass, which means you will receive the full intensity. You guys get it? When you move it to 90 degrees, which means the wave now is like exactly like that, 90 degrees to the transmission axis. So all of the wave will be blocked. 180 again full, 270 blocked, 360 full. So it is going to show you a cosine wave like that. That is the reason it's a function of cosine. Do you guys understand that?
Yes.
So why is the intensity zero in 90 degrees?
Because this is this transmission axis means that the Polaroid has molecules aligned vertical, right? Good.
Oh yes, yes, yes.
So if it is this 90 degrees to the transmission axis, it won't allow any wave to pass. That's why it's fully cancelled. That's why.
Yes.
Okay, please draw this. All right, now let's have a look at a question that they're going to give you. The questions are: question 1, plane polarized light of intensity 12 watts per meter square is incident at a Polaroid. Calculate the intensity when angle between transmission axis and incident light is number 1 45 degrees, number 2 60 degrees. Can you guys please find it out quickly while I write the next question? All right, kids. First one, please. Who got it?
So I got 6 and 3.
6 and 3. That is correct. So all you need to do is I equals to incident wave is 12 and cosine square 45. If you don't know how to square, take the square on the calculator, all you need to do is it's gonna be uh, 12 basic 12 times, put a bracket, cosine, write 45, and then square the bracket like that. So it's gonna be 6. Do you guys understand that?
Yes.
And the other one will be 12 cosine square of 60. This will come out as 3 meter per second, watt per meter square. Is that clear?
Yes.
Oh, good. Now try the next one, please.
question in the toggle. I didn't know where to put it. This one. Question number 28.
ये है किसका?
O level physics.
ये
अब ये इसमें आ सकता है इलेक्ट्रिकल क्वांटिटीज में, क्योंकि उन्होंने ये देखें, यू लुक क्लोजली इनफ, वो कह रहे हैं डिस्क्राइब द यूज ऑफ वोल्ट मीटर्स एनालॉग एंड डिजिटल, बट इलेक्ट्रिकल सर्किट्स में नहीं आएगा ये।
नहीं,
वो तो ऊपर वाला आ गया ना इलेक्ट्रिकल सर्किट।
ये क्वांटिटीज का ही है।
ये क्वांटिटीज का है।
Yes.
ओके, और अगर एमीटर वाला आया तो वो भी क्वांटिटीज में आता
क्वांटिटीज में।
है। ठीक है, थैंक यू।
All right, kids, you got an answer? Okay. Give me a second, please, while you do this.
So I got 72.5.
17, no. Basically, what you guys need to remember is that I will be equal to, it says it's 30% of I naught, right? So can I say it's I equals to 0.30 of I naught? Can I say that, please?
Yes.
Then I'm going to use that equation. What is the equation? I equals to I naught cos square theta. So I is 0.30 I naught, and I naught is I naught, and cos
So
square
is
theta.
it 6.8?
It's 56.8, yes. So then you take 0.30 equals to cos square theta, take under root on both sides. So it will be cos square theta, cos theta equals to under root 0.30. Then take cos inverse of this one. So you should be getting something like 56.8 degrees. Is that clear?
Yes.
So these sort of questions will come. So you guys need to be aware of this, okay? Good. So, any more questions you have, Raza, Furqan? Furqan, everything is clear. Shazay, Basma, Abdullah, about you, Fatima. Furqan, are you there? Imal,
No doubts.
okay. Dania,
Yes.
good. Now on to The questions from Asma. So I'm gonna stop the recording now. If you want to go, you have another class, you can go.
Thank you.